everyone, and welcome back for another deep dive. Today, we are going to be jumping into the world of mixture of experts models,
MOE for short.
MOE for short. And we're going to be looking at a new paper,
A new approach.
yeah, called ReMoE.
That's right.
So, imagine like having a team of AI specialists, each one like a master in their own little domain, and they're all working together to try to solve some really complex task.
Right. It's like this fascinating idea of instead of having one huge monolithic AI, you've got all these smaller AIs that specialize and can kind of come together to solve a problem.
Yeah, like I was thinking of like a medical team, right? You've got your cardiologist for heart issues, and then you've got your neurologist for the brain, and, each doctor has their own, specific area that they're an expert in.
Right. And it's like, how do you know which doctor to call on for this problem?
Right, exactly. That's the big question.
And that's where the routing aspect of MOE comes in.
That's where ReMoE shines. So tell me a little bit more about ReMoE. What is it? What makes it so special? What makes it different?
Okay, so ReMoE stands for ReLU Mixture of Experts. And the ReLU part is really important. We're going to get into that.
Huh.
And we're going to be looking at this paper today from some brilliant folks over at Tsinghua University.
Okay.
And they titled it ReMoE, Fully Differentiable Mixture of Experts with ReLU Routing.
Fully differentiable.
Yeah.
Okay, that sounds kind of interesting. What is ReLU and what is this routing?
Okay, so you can think of ReLU like a dimmer switch.
Okay.
And what that allows the model to do is it allows it to gradually adjust how much each expert is contributing to the solution rather than just like an on or off switch.
So it's not like you're in or you're out. It's like you can kind of like fine tune each expert's involvement.
Exactly. And that's what makes it fully differentiable. And that essentially means that it's easier to train and it's easier to optimize.
Oh, so it's like a team that's constantly learning and refining how they work together so they become more efficient over time. And I would imagine better training leads to better results.
That's the idea.
So it's not just clever in how it's selecting its experts. It's actually like designed to get better at choosing the right experts for the job.
Yeah.
But I'm thinking, doesn't that raise a concern like about, expert burnout?
Yeah.
What if some experts end up doing like way more work than others?
That's a great point. You don't want a bunch of overworked AIs or, lazy AI.
Oh, wait, slackers.
Yeah, exactly.
Yeah.
So you need some kind of balance. And this is where ReMoE's built-in load balancing mechanism comes into play.
Okay, so tell me about this load balancing magic. How does it actually work?
So it uses this technique called adaptive L1 regularization. And basically, without getting too much into the weeds, you can think of it as like it's got this system that can monitor how much work each expert is doing, and it can automatically adjust to make sure no one is getting overloaded or underutilized.
So no overworked experts and everyone's kind of contributing.
Exactly. And one really fascinating thing about this load balancing is that it creates a natural three-stage training process for these models.
3 stages. Okay, I'm intrigued. Break it down for me.
So in the first stage, almost all the experts are active.
Yeah.
And they're kind of just getting a feel for the problem at hand.
So it's like an all hands on deck situation?
Right. And then as training progresses, the ReLU routing starts to kick in, and it starts to get more selective about which experts it's using.
So it starts broad and then narrows down to the specialists as it learns more.
Exactly. And then finally, the model kind of reaches this stable state where the experts are well-defined and the workload is balanced and everything's just humming along.
It's like a well-rehearsed orchestra at that point. Everyone knows their part.
Exactly.
So we've got the ReLU routing to keep things smooth. We've got the adaptive L1 regularization for a nice balanced workload. And then this 3-stage training process to refine the expertise. It sounds like a pretty impressive system.
Yeah, it's pretty cool.
But I have a feeling there's more to the story.
You would be right. There's one other thing that ReMoE does that ties it to something you use every day.
Oh, okay. I'm hooked. Lay it on me. What is it?
File compression.
File compression.
Okay.
Okay. I did not see that coming. How are those two things related?
So ReMoE can actually adjust how many experts it's using for each piece of information.
Dynamically.
Dynamically, yeah. And what's really cool is that this is very similar to how Huffman coding works.
So we're talking about the same Huffman coding that's like used to shrink down massive files.
The exact same one.
Okay, wow, that's amazing.
Yeah, and so like Huffman coding makes things efficient by assigning shorter codes to symbols that appear more frequently. ReMoE tends to use fewer experts for pieces of information that are simple or that it sees a lot.
So it's being smart about how it's using its resources. It's
Right.
prioritizing efficiency.
Exactly. And then for those more rare, complex pieces of information, it's going to call on a larger set of experts.
Gotcha. So it's like it knows when to bring in the big guns.
Exactly. And then this ties into the idea of these experts specializing in certain areas, which is called domain specialization.
So it's like you've got a team of specialists, and each one not only knows their stuff, but they know when to step up and when to let the others take the lead.
Exactly.
Okay, I am starting to see the bigger picture here. This isn't just about having a team of experts, it's about orchestrating their expertise in a way that's dynamic and efficient and adaptable.
Right.
This is really groundbreaking stuff.
It is.
But I think it's time to dive into the research and see how these claims actually hold up.
Okay, let's do it.
All right, so let's take a closer look at how this team from Tsinghua University actually put ReMoE to the test.
Yeah, let's see what they found out. So let's get into some of the details of their research paper.
All right, let's roll up our sleeves and see how they actually built and tested this marvel of AI.
So they started with this popular framework called Megatron LM,
Okay.
which is kind of like a powerful toolkit for building large language models.
So they didn't necessarily have to start from scratch. They had some good tools to build on.
Exactly. And they also incorporate some advanced techniques to kind of like boost performance,
Okay, like what kind of stuff?
like grouped query attention, and they use the SWGLU activation function.
Okay, so they're taking what we know and adding their own cool stuff on top of it.
Right.
Very cool.
So they tested it with 3 different model sizes, small, medium, and large.
Okay, so not just small scale problems. I wanted to see how it would scale up.
Exactly.
Okay, so what was the difference between these sizes?
So the main difference was the number of parameters,
Okay.
which is basically like, the brain power of the model.
Yeah.
And the small model had 182 million parameters.
Oh, okay.
And the large model had 978 million parameters.
Oh, that's a big difference.
Yeah, so they were really testing it out.
Yeah. Okay, so they had all these different models. What about the training data? Where did they get all that juicy info to feed these models?
So they trained it on this massive data set called the pile. And it's this collection of text and code from all over the place.
Yeah.
Books, websites, scientific papers, all sorts of stuff.
So like a diverse real-world data set.
Exactly.
Yeah.
And they trained it for 60,000 steps.
Wow, so that's a lot of training.
Yeah, like a marathon for a computer.
And I'm sure they gathered a ton of data from all this training. How did they actually evaluate how ReMoE performed?
Right. So they used a bunch of different metrics, but one of the main ones was validation loss.
Right.
And basically that measures how well the model can predict the next word in a sequence.
So it's like a test of how well it's learned from all that training data.
Right.
Okay. Did they only focus on language tasks, or were there other things they tested it on?
So they also tested it on what are called downstream tasks,
Okay, what does that mean?
like specific applications,
Okay.
like question answering or text summarization or code generation.
So looking at both the general language understanding and then the ability to like actually solve problems.
Exactly.
Okay. You mentioned earlier that they tested it against like another top model.
Right? They compared it to what's called token choice dropless top K routing, or DOE.
ReMoE. All right, so that was like the reigning champ in the MoE arena.
Right.
Okay, so it's the newcomer versus the veteran.
And ReMoE consistently outperformed DMOE.
Wow. All right, so it wasn't just like a tiny edge, it actually did significantly better.
Yeah, especially as they increased the number of experts.
Okay, give me an example.
Like on one task, ReMoE, with 128 experts, got 42% accuracy,
Okay.
while DMOE, with the same setup, only got 41% accuracy.
I mean, 1% might not sound like a lot, but in the world of AI, that's huge.
Right.
That's a big improvement. Okay, so what else did they find?
So as they increased the model size and the task complexity, ReMoE's advantage actually grew.
Oh, so it scales well, and it keeps that performance edge even when things get more difficult.
Right.
That's a really good sign. You mentioned something earlier about fine-grained ReMoE. What is that?
Oh, yeah. So fine-grained ReMoE is kind of like taking the concept of specialization to another level. Instead of just having, experts divided up by tasks, you can actually split each expert up into even smaller sub-experts.
Whoa, okay, that is getting granular.
Yeah.
It's like instead of just having a cardiologist, you've got a cardiologist who specializes in arrhythmias and another one who specializes in heart valve disorders.
Right.
So what did they find when they increased this granularity? Did it lead to anything interesting?
Yeah, so as they increased the granularity, the performance of ReMoE kept getting better and better. And in some cases, it actually broke through a theoretical limit they had calculated.
Wait a minute, they broke through the ceiling. How is that possible?
So they had calculated this upper bound of how well they thought the MoE model could perform given a certain number of parameters.
Okay.
And the fine-grained ReMoE actually exceeded that limit.
So it's like saying this is the absolute best you can do, and then it goes and does even better?
Right.
That's incredible.
Right.
So it's like the whole is greater than the sum of its parts.
Exactly. And
Yeah.
it shows this incredible potential of breaking down these complex tasks into smaller and smaller subtasks,
Mm.
and then having all those experts work together.
This is really exciting research. It's like ReMoE is just pushing the boundaries of what we thought was possible with AI.
It is.
But as with any powerful tool, there's got to be some potential downsides or challenges. What are some things we need to be mindful of as this technology develops?
Right. So while it shows this huge promise,
Yeah.
it's not perfect.
Okay.
And one of the things we talked about before was load balancing, making sure no expert gets overloaded.
Right.
And while it has a mechanism for this, it's not always perfect.
Okay, so what kind of issues did they see?
So they noticed that there was some unevenness in how the information was distributed among
Well,
the experts.
so it's like a team where some people are always swamped and others have a lot more downtime. Well,
Exactly.
very productive.
And while it wasn't a major problem in their experiments, it is something that they're trying to refine. And they're looking at ways to improve the L1 regularization technique.
So fine-tuning that project manager to make sure everyone's got a fair workload.
Right.
But I'm curious, why is load balancing so critical? Like, what happens if things get really out of whack?
So in really bad cases, you can get what's called routing collapse.
Hmm.
And that's where the router basically just gives up and sends all the information to the same expert.
It's like the project manager just throws in the towel and says, you handle it all.
Exactly.
Okay, that doesn't sound good.
Right, because then you lose all the benefit of having all these specialized experts.
Right, you're basically back to a single AI.
Right, and it defeats the whole purpose.
Okay, so load balancing is really important. So what else are they focusing on for future research?
So one of the most interesting things is this idea of domain specialization, how individual experts become really good at certain things.
Oh yeah, that's the part I'm really excited to hear more about. Did they find specific examples of this happening?
Yeah, so for example, they had one expert that was consistently really good at handling code-related text.
Like a code whisperer.
Yeah, and another expert that was really good at understanding scientific language.
That's incredible. It's
Yeah.
like watching them evolve and adapt to the information they're given and like carving out their own niche.
Yeah, and this seems to emerge from how they've designed ReMoE.
Okay, remind me again how that works.
So the ReLU routing, our dimmer switch,
Yeah.
that allows for this fine-grained control over how much each expert is contributing.
Okay.
And then the dynamic allocation allows the model to adjust how many experts are involved based on the complexity of the task.
Gotcha.
So when you combine those two, it creates an environment where these experts naturally gravitate towards the types of information that they're best at.
So like natural selection for AI experts.
Exactly.
So those best adapted to a specific domain, they're the ones that thrive.
Right.
But are there any downsides to this specialization? Like, what if an expert becomes too narrowly focused and they can't handle anything outside their little niche?
Yeah, that's a valid concern. You don't want your AI to be super good at one thing, but completely clueless about everything else.
Like an AI that can write brilliant code but can't understand a simple email.
Right. So researchers are looking at ways to encourage cross-training between these experts.
So it's like making sure they have a broad foundation even as they develop their specialties.
Exactly.
Okay, this is fascinating stuff, but I have a feeling we're only scratching the surface here.
Right.
What other research avenues are they exploring?
So one area that's really interesting is the connection between ReMoE's dynamic allocation and something called the Huffman tree.
Wait, didn't we already talk about Huffman coding, like the file compression thing?
We did, but there's another layer to this connection that's even cooler.
Oh, okay. I'm intrigued. Tell me more.
So they found that how ReMoE assigns experts is actually similar to how a Huffman tree is structured.
Okay, and remind me what a Huffman tree is.
It's a way of representing data efficiently based on how frequently it occurs.
Okay.
So in a Huffman tree, frequent symbols are closer to the top of the tree, and less frequent ones are further down.
Gotcha. So it's all about optimizing based on how often something shows up.
Right, and ReMoE seems to be doing something similar.
So it's like, for those common pieces of information, it only uses a few experts, like it's compressing its resource usage.
Exactly, and then for those more rare things, it will activate more experts to give it a more detailed representation.
So ReMoE kind of has this computational intuition. It knows when to bring in the A-team.
Right, and this connection to the Huffman tree suggests that it's not just randomly assigning experts, it's learning to do it in a way that's super efficient.
This is really clever.
Yeah, and it has implications for how we design more intelligent and efficient AI systems in the future.
This is really incredible stuff. ReMoE is full of surprises.
It is.
And it seems like we're only beginning to understand what it can really do. But for now, I think it's time to wrap up this part of our deep dive.
Okay.
We've gone over the technical details of the research, and we've talked about domain specialization and this unexpected connection to the Huffman tree.
Yeah, it's been a whirlwind tour of AI.
It has, but the story of ReMoE isn't over yet.
Welcome back to our ReMoE deep dive. We've gone pretty deep into this model now, from its routing and load balancing to that domain specialization.
And of course, who could forget that Huffman tree connection?
Definitely not me.
Mm-hmm.
But I'm curious now about the bigger picture. What are the implications of ReMoE's innovations? How could this shape the future of AI?
One of the things that's super exciting is that it could really democratize large language models.
Okay.
So right now, training these massive AI systems takes a ton of computational resources.
Yeah.
And it's really limited to just a few big tech companies or like well-funded research
Like
labs.
an exclusive club with a huge membership fee.
Exactly. But ReMoE, because it's so efficient and scalable, it could change that.
Oh, okay. So by distributing the workload, it's like you can do more with less.
Right. And that means that more people can experiment with and contribute to AI research.
So it's opening the doors to that exclusive club.
Right. And that could lead to a ton of new innovations and applications. Yeah. I mean, it's really exciting to think about all the possibilities. What other areas could ReMoE impact?
Personalized AI is another big one.
Okay.
So imagine having an AI assistant that's not just generally smart, but actually specializes in your interests and needs.
So instead of like a one-size-fits-all, you've got something that's really tailored to you.
Exactly. And ReMoE's domain specialization makes that possible.
Like you could have an AI that helps you with research or code in your style or gives you financial advice. It's like having a whole team of experts in your pocket.
Right.
That's pretty amazing. But, with all this amazing potential we have to talk about the challenges too, are there any downsides to ReMoE that we need to address?
Yeah, for sure. I mean, like in any technology, we need to be careful. One concern is over-specialization.
Yeah.
Like, what if the experts get so narrow in their focus that they can't do anything else?
Right. We don't want an AI that's a brilliant chess player but can't boil water.
Exactly. So researchers are exploring ways to encourage like cross-training between experts.
So it's kind of like giving them a well-rounded education.
Right.
Okay, so what other challenges are out there?
Another big one is interpretability.
Okay, what's that?
So as AI gets more complex, it's harder to understand how it's making decisions.
Yeah.
And that's especially true with MoE models, where you've got multiple experts involved.
So it's like you see the end result, but you don't know exactly how it got there.
Right. And that can be a problem, especially in fields like healthcare or
Okay.
finance, where trust is really important.
Yeah, you wouldn't want to take a medical diagnosis without knowing why the AI came to that conclusion.
Exactly. So researchers are working on making MoE models more transparent.
So it's like being able to look under the hood and see how the different experts are contributing to the decision.
Right. And maybe even having the AI explain its reasoning.
That would be amazing. So we've covered a lot in our ReMoE deep dive, from the technical nuts and bolts to these really big picture questions about the future of AI.
Yeah, it's been quite a journey.
It has, but I think one of the biggest takeaways for me is that ReMoE represents a whole new way of thinking about AI.
Absolutely. It's not just about building bigger, more powerful models. It's about designing systems that are efficient and collaborative and adaptable.
ReMoE is like a glimpse into a future where AI is more accessible and personalized and transparent.
And where it can truly work alongside humans to solve some of the world's toughest challenges.
It's a future I'm definitely excited to see unfold. Thank you all for joining us on this incredible deep dive into the world of ReMoE.
Until next time, keep learning.
And keep exploring the amazing possibilities of AI.